Hello, and welcome to a little video about Target 4B in which we look at transformations. Now we're going to begin by proving each transformation. Number one is our base graph. This is our original. We're going to compare everything to this graph. So let's graph it so that we can compare. I'm choosing three easy points to use. I'm going to use x, -1, 0, and 1. The reason I'm using them is because they're small numbers, they're easy to do. Okay, so to get my answers for what g of x equals, I use my calculator. I plug in 2 to the power of -1, we get 1/2. 2 to the power of 0, we get 1, and 2 to the power of 1, 2. Now I like to rewrite my table as points. It just makes it easier for my brain to process it. I also just highly recommend it for my students. Just makes it easier. Okay, let's graph this. -1, 1/2 is the point right here. 0, 1 is right there. And 1, 2 is right there. I'm going to connect it with a shape that I call a swoop. And this is our basic exponential function. Now, let's take a look at transformations. In number 2, we have a +1 on the outside. Now this +1, I'm just going to say it right off the bat, it means up 1. Now we can't trust what I'm saying until we prove it. So let's prove it. I have x, I have g of x, and I'm once again going to use -1, 0, and 1, just because they're easier numbers to use. Now in our calculator, the way you're going to plug it in is you're going to plug 2, caret -1, and make sure to scroll to the right to get that +1 on the outside. When I do that, my answer is 1/2. Next, 2 to the power of 0, and then +1, I got 2. 2 to the power of 1, +1, 3. Okay, so let's write down the 3 points that I have. I've got -1, 1/2, 0, 2, and 1, 3. Now hopefully after graphing this, we can compare it to number 1, and you will see that we indeed took that first function and moved it up. Okay, -1, 1/2 is right here, 0, 2, and 1, 3. Let's draw our swoop. There's our function. So take a look at number 1 and 2. Hopefully you can see that it looks like we took number 1 and we scooshed it up. Now in number 3, we have a -1 on the outside of our function. This means down 1. Now, don't believe me just yet. Let's prove it. First, I'm plugging in -1. So 2 to the power of -1 minus 1 gives us -1/2. 2 to the power of 0 minus 1 gives us 0. And finally, 2 to the first minus 1 gives us 1. And I'm still using -1, 0, and 1 because they're just nice points to use, nice easy numbers to plug in and work with. Okay, so here are my 3 points. -1, -1/2 is down here. 0, 0 is right in the middle at the origin. And then 1, 1. Let's draw our swoop. Now I'm going to zoom out, and hopefully you can see that compared to number 1, it looks like in number 3, we took the graph and we pulled it down. Okay, so that's transformations up and down. So what other directions do we have left? Oh, left and right. So let's take a look at number 4 and see what that does for us. Okay, so number 4, I hope you notice a little +1 in the exponent. So it's not outside, it's in the exponent. This means left 1. Now again, you can't trust me just yet. We do have to prove it. Then, once we see that it's true, then you can trust me on it. All right, let's begin by plugging in -1. So 2 to the power of -1 plus 1. This time, make sure you're staying in the exponent. Click the equals, 1, 0. 2 to the power of 0 plus 1. I got 2. And then lastly, when we plug in +1, 2 to the 1 plus 1 gives us 4. Beautiful numbers. So we have negative 1, 1, 0, 2, and 1, 4. All right, negative 1, 1 is here, 0, 2 is here, and 1, 4 is right there. Now this might be a little harder for some people to see. I, in particular, find the movement to the right hard to see, but this is a movement to the left. So I'm going to zoom out. Hopefully you can see that between number 1 and 4, we took the shape and we moved it 1 to the left. Okay, last direction. Last direction. Let's move it to the right. So when there's a minus 1 in the exponent, that means to the right 1. Now I know that's really the last option we have, but again, can't trust me until we prove it. So let's prove it. That's how we do it in math. Okay, so let's begin by plugging in negative 1. So 2 to the power of negative 1 minus 1 gives us 1/4. Let's plug in 0. 2 to the power of 0 minus 1 gives us 1/2. And finally, 2 to the power of 1 minus 1 gives us 1. All right, let's write down those 3 points. Negative 1, 1/4. This is going to be a little weird to graph. 0, 1/2, and 1, 1. Okay, negative 1, 1/4 is like right there-ish. 0, 1/2 is there-ish, and 1, 1 is there-ish. Okay, let's draw it. So there's your little swoop. I'm going to zoom out. You can kind of see from number 1 to number 5, our graph moved to the right. Huh. Actually, I can see it pretty well this time. Huh. Very nice. Good job, my own brain. Okay. Now, in 1, 2, 3, 4, and 5, we proved the transformations happened the way I said they would. So what we can do now in number 6, 7, 8, and 9 is use that information to create equations. For number 6, we're going to take 4/5 to the power of x and we're going to move it to the right. In order to do that, we are going to subtract 2 in the exponent. Well, if moving to the right means subtracting 2, moving to the left means we're adding 2. Oops, I didn't mean to do that. There we go. Beautiful. All right, now let's move this same function up and down. Now when we're moving up and down, we're going to create the addition and subtraction outside of the exponent. Up is 2. Up is plus 2, not 2. And if up is plus 2, well then down must be minus 2. And make sure, again, that when you're going up and down, your plus and minus is on the outside of our function. Okay. Now, let's get even easier. So we figured out how to manipulate our algebraic functions. Now, let's quite literally manipulate our graph. So here we have a graph, and we'd like to move it up 4. Now, what I like to do is grab 3 points. I grab 1 point from the right side, 1 from the middle that's crossing the y-axis, and then, of course, 1 on the left, just to create a nice picture. Now we're going to move up 4. Let's do it. This graph's going by 2, so 2, 4, 2, 4, 2, 4. New point, new point, new point. And of course, our nice swoop. Mine is not as beautiful as yours is probably, but that's okay. Let's do the same thing here, except this time we're moving it down 4. I'm going to choose 1 on the left, 1 in the middle, and 1 on the right. It doesn't matter which 3 points you choose, just make sure to choose 1 on left, right, and middle. All right, let's go down 4. 1, 2, 3, 4. 1, 2, 3, and 4. 1, 2, 3, 4. All right, point 1, point 2, point 3, and of course, let's draw. Oh, that didn't work. Let's try again. Let's draw a nice swoop. There we go. Beautiful. Wow, Why did it do that? That's so rude. I even had a nice swoop going, and you saw that happen. That was so mean, computer. Okay, this is the best I can get after that. How sad. All right. So, in number 11 and number 10, we quite literally took the graph and we scooched it down. Let's do that one more time for number 12. We're going to move this 6 units up. I'm going to choose a point on the left, I'm going to choose a point on the right, and I'm going to use the one in the middle. All right, let's go. Up 1, 2, 3, 4, 5, 6. Up 1, 2, 3, 4, 5, 6. And up 1, 2, 3, 4, 5, 6. Oh, so much counting. All right, there's the 3 points. Draw a nice little swoop, and we're good to go. All right. I hope you found this helpful. If you have any questions, of course, remember you can always contact me or your teacher. Otherwise, have a wonderful rest of whatever day it is for you. Bye!